Now, up to this point in our course, we have looked at a lot of different aspects of C++. We've talked about technicalities and some of the specific memory type functions and actions with things like pointers and arrays and variables and all sorts of things. And now I want to talk about how we can put those things together and the structure that we can use with C++ to make some really cool things happen. And what I'm really going to key in on for the next few videos is something called object-oriented programming. Now, you may have heard of this. If you have, you might want to skip this video. Pay close attention to the next few, though. But with object-oriented programming, we're referring to the structure of our program, how it's put together and how it runs. It breaks the whole programming task for our entire application into discrete objects or collections of code. Now, these are self-contained entities. They have an identity, they have a name, and they have certain operational characteristics. There are things they can do. There's certain states of data they can store, variables with values, and that sort of thing. Now, when we talk about object-oriented programming, don't want to turn this into a college class or anything, but there are 4 pillars of object-oriented programming, and depending on which propeller head you talk to somewhere, and I use that term of endearment there because I am one, but the propeller heads that are out there, some will say there's 3 pillars, some will say 4, and then there's always that one that says there's 23, and they just kind of blab on and on and on and on. Okay, just avoid those people. Well, let's talk about the 4 pillars in this video. There is something called encapsulation, data hiding, inheritance, and polymorphism. All right, these are the 4 you hear most about. Now let's talk about each of these briefly. Encapsulation refers to the fact that when we build objects in our software, that an object encapsulates functionality. Okay, this is where we provide black box functionality. Good example, I create, very similar to creating a function that inoculates the dog, right? I've got my veterinarian's office and I've got a program written, and anytime we inoculate a dog, we call the inoculate function. Well, that thing's got 100 lines of code in it. It's connecting to a database. It's passing Spot's name. It's passing what kind of stuff we're inoculating into Spot, what it's taking care of, when he needs a booster, all kind of stuff. Do we need to know how to connect to the database and all that? No, it's encapsulated in. Now we take that to the next level and we create classes that we can use to instantiate objects that do this, and it gets pretty exciting. The user doesn't have to know how to do what this particular object does. It just needs to know how to ask it to do it. Now, close on the heels of that is a concept called data hiding. Now, you're going to notice there's a little bit of overlap with all 4 of these aspects. Okay? Now, while encapsulation takes complexity and just kind of piles it up in a box and we don't have to understand what's going on, data hiding in that process means that the internal state of that object doesn't have to be disclosed. A better way to say that is certain data, such as the name of the database, how we connect to it, where it's located, all that, the commands we write to retrieve the data, can be protected. The end user never sees exactly how we connect to the database or whatever. The object privatizes that, or it keeps it private. You can't see it from the outside, from the object that you create from the class, and so it's protected or it's hidden. Next, and this is a big one, is inheritance. Now, we all know what inheritance is out here in the physical world. It's when a loved one or a stranger or somebody leaves this world and they leave their worldly belongings to us. Okay? And with just a little luck, those worldly belongings are worth millions and millions, right? Well, the same type thing can happen in software code. And with inheritance, an object can inherit functionality from another object. All right? Then you can add even more functionality. You'll see an example of this later on in some code in the course. All right? Now, this is also referred to as data reuse. If I create a class that's got 14 really great functions, and then I want to create another class and I need those 14 functions, I don't have to rebuild them in the other class. I can simply inherit, and those functions will be available in my new one that is inheriting those functions. We'll talk more about that later and get into all the nerdy terms on it, okay? Now, polymorphism is one that sounds really cool, but what it really means is that we can put the same action in different classes and give it the same name in different classes. Now the end user may not realize that they're actually working with a different class. All they know is they just type the same name and different stuff happens. Alright, so polymorphism is the ability to get different actions out of the same name. Now, lots of bad examples out there, and you can use this for a lot of these, but a good idea is polymorphism is a car's accelerator pedal. If I get in a 1963 Volkswagen, if there is one, 67, and I press the accelerator, it makes the car go. All right. If I get into a 2011, Range Rover, press the accelerator button, it goes. All right. So the accelerator is polymorphic in that sense. Okay. Doesn't matter which car I get in, I press the accelerator, the same thing happens. Now, there's probably a whole lot more going on in that engine in the Range Rover than there is in the 67 or 63 Volkswagen, but I don't care. I do the same thing. Whatever needs to happen happens. Okay. So that's some of the basics of object-oriented programming, and in the next few videos we're going to dig into object-oriented programming a little bit, peel off a layer at a time, and show you some of the cool stuff that object-oriented programming brings you in your code.